Hey guys, welcome back to another video. So this time, today we are going to go over our our folder structure, file structure, and what kind of exists there, what they're for, all of that stuff. Okay, so backend obviously it is TypeScript. So we have our tsconfig, we have our package JSON. We're using Yarn for all of this stuff. As you can see, I did have got that all set up. So you have our terminal down there. So everything under our source directory. For the backend, we do try to keep the front end and the back end similar in the aspect that they have a, the front end, you have your pages or your components or your views, and then the service that reaches out and does all of that stuff. The back end is similar in the way that we have the entry point, which is the API, and then we have a service layer and a data model or a data source where we get that data that we talked about in a previous video in the architecture stuff. So anyway, it's similar in that way, but obviously there's some pretty big differences as well. So with the backend here, just to kind of start us off going down the proper data flow that we have, we're going to come into our app, right? Just a regular app that we have started. And the first thing that's going to happen is we're going to start going through our middleware. And as we come through our middleware, we just have them registered here in our app.ts. Obviously, we can pull those out into a separate path or anything, but it's easy enough here where we can get our global error handler and everything as well. So as we come in here, the first thing that we do is on our root, we register our version of our response function. So we can have a standardized response with these guys. So if you have a paginated endpoint, right, you can have your paginated. We can send wrap data, which wraps whatever we're saying in data. So we have that standardized response as it comes through. Error handling, whatever it is, right? So that's kind of what this guy is. The next thing we do is we go into our authentication for anything on the API. And what this guy will do is just that. He authenticates or authorizes you, depending on what's happening. And we can kind of get into the weeds of what that does later. So that's what he does. And then we go into validation. Again, I know I talked about this high level in the architecture video for the validation, but basically he ensures that all of the data that we want exists before we get into our endpoints and our routes. And he handles that in the middleware. So one pretty common issue that people will come into is they'll set a breakpoint in their API or a console log, preferably a breakpoint, but if you're trying to trace, you think it's a timing issue or something like that, you might put it in a console log, but they'll throw a breakpoint in their route and then it won't ever get hit and they can't figure out why. And that can happen in a few different places, as we'll kind of see. So the first is in our middleware here, right? In one of these files, something is happening, something is throwing an exception, hanging, it's not returning a response, whatever it happens to be. But it's having an error in here that isn't actually once it hits that route. So that's kind of the first place to start with the data flow, is coming down through the middleware. The next thing that we're going to do is we have our decorators, right? So decorators with TypeScript are really nice if you've used them in any other language. They give you a very nice, clean way of handling certain things on some of your routes. So in this case, this is for handling our public URLs. We can set this up as a decorator. I'll show you that here in a moment when we get into the API of how this works and how it looks. But just know that the decorators are here, and it does happen in the decorator before it's actually going to get into your route. So again, just another place where you can have an issue if you're trying to debug something and it doesn't actually register in your route, is the decorators as those go through. The next thing that we're going to go into is our API. So the API is set up in a few different ways. We have our API, right, directory, and then we have our endpoints with our index. Our index is a factory that will dynamically read the endpoints folder and pull out all of the routes that we want. So we have our API here with the endpoints. You can see in this case we have our users or user API that has a few different things. Obviously, it's not in a happy state at the moment, but that's all right. So anyway, this is where our routes live. As you can see, we have login with token. Right, we have our default patch for an update. Just a few there, so you can see the examples. They are the different HTTP types with some other stuff. It's all class-based and everything in here as well. This is where the decorators kind of come into play. So we have the bound method, which binds the scoping of the this keyword in JavaScript, TypeScript. Another decorator, for whatever it happens to be. In this case, we have this old one for determining whether it's the admin portal, and it did its logic. Same thing with access scopes. But this is how decorators exist, how you utilize them, and then those just kind of map to this guy. So if you wanted to see the public URLs, right, here's a public URL that registers to our public URL decorator up here with that register route. Just making sure that it bypasses authorization, authentication on those endpoints. So that is our decorators and the general API structure of what you're going to see. Again, the big emphasis that we want here is that the name of our file stays consistent for the most part with what we're going to do. So you can see we have the user service that's imported here. So we can then talk to the user service, which will then talk to the user database layer, which then talks to the user table. Right, so we keep that continuity. So if you have an issue, you're trying to debug something or you want to add a new endpoint to this guy, right? It makes sense. It's generalized. It's easy to follow. So what these paths would be is set up in our general API and in the index for our factory here. And you can see we have the API prefix name. So all this does is it splits on our file name, and it takes the first index of that split. So in this case, it would be user. So if we go back to our API, we have API v1 user login with token, API v1 user login, API v1 user, right, for our patch request. That is one thing to note is we do keep those on the root for our basic requests, or get, create, update, delete. We keep those on the root of our route, as opposed to having a user create. We can just do a user with a post, and anyway, that's kind of how that is set up and how it's determined. And then how you can see the decorators in here and everything else. So the next thing that you're going to see is a lot of the TypeScript types that are in this guy. So that lives under our types folder. As you can see in here, there are several of these guys. The one to start with is our API. So a thing of note is the communication between the client and the server. The server is what drives it, right? It is, not necessarily what drives it, but it determines and defines how the clients or third party or whomever, it doesn't matter, speaks to it and what it's going to give you back. Right, the front end doesn't say, "Hey, server, I'm going to do this thing for you, and this is what you're going to tell me." The back end is what kind of drives those interactions of this is how you talk to the server. Right, it's API first in this case. This is how you talk to the server, and this is what the server is going to give you back, and you conform to what the server is going to do. So with these guys, we declare a namespace, so we can use API anywhere. Again, if we go back into that user API, right, you could see. It's not API v2, but it's API, user, response, whatever. And with those guys, we do set everything up to the request. So this is how you make the request, and this is the response that you're going to get back. So in this case, we have the API user request update, right? So you can update the first name, last name, primary email. Again, in this case, this is not set up all the way, but as a working example, for a login, right, you're going to have a username and a password. And what the response is going to be for a login is the user model from our database. You might ask, what is the user model? Well, in this case, the user model is nothing. but it needs to be, right? So the way that the models work is models are the exact representation of what the database is going to be. So in this case, we would have, as we have our database up here, we would have our ID, which is a number. We would have our first name, which is a string. These, if you remember from the database video when we set up the table, these guys I believe we set up as not null. We can verify that real quick and just kind of look at them. Yes, not null. No, not null. I do think we have, it would probably be good just to have, I mean, it doesn't matter, but those guys are not null. So if they were null, right, we would want to have a, if for example, the last name was null, we would say string or null here. And this is important to do this so the front end knows that this value may not be there, right? It could be, but it might not actually have a value in it. You're going to have that key, but the value might actually be null in this case. So it's important to make sure that your types are done properly, so the front end, knows what the data actually is. This guy will come in as a Boolean, and then we have our created on, which is a date string value, right? We put it as a date string value, date or string in this case, because it is truly a date value. It is just a stringified version to be stored in the database, and then we convert that type as it comes out of the database connection. So anyway, there we go. Now we have our interface set up. You can see it's an exact representation of what the database is, which is exactly what we want in the models. Now we know login is going to give you back this guy, right? Which is great. We have our custom express. These handle kind of our custom express version, basically. So we have our custom headers that we're going to have. So our XAuth token, that's how you authorize with the token. If it's multi-tenant, we have a company ID, UQID for third-party access. If it's multi-region, we have that. If we have a session or anonymous user, we have the access for that. Requester details is a pretty good standardized way to, again, for multi-user, multi-tenant system to be able to pass through some specific data relative to that domain of what you're going to do. So if you want to have the user roles on all of the requests, or the user role on all of the requests for the user making the request, right? You can have that stuff in there, the company that user belongs to, so on and so forth, all of the different methods that are accepted through the API. The way that request, so a wrapper around the standardized express request. So we always tack on a user, we tack on the company ID, we tack on our custom headers that we just looked at, right? That's kind of where this stuff lives. And then the response data. So we have the send data, we have send a data external, we have a raw, we have an error, we have all of these things that we can send that are, again, are a wrapper and extend from the express response. So they're kind of our own flavor. And then obviously we put a generic on those so you can tell what type it is that's coming through. Again, to see a working example of that, we have, let's see, any of these, it doesn't matter. So, but we have our artist request, right? This guy, he's sending through a paginated query, and the response is that template type of a get on this guy. So that's what this guy is. We have our custom. These are for our custom queries or query methods for MariaDB when we write our queries. So we don't use an ORM. We write all of our own raw queries. We have our node stuff. Again, for control of everything, this is actually, we don't even use global in this case, I don't think, but he's there in case we need him. And then Red Sky is just generalized interfaces that don't necessarily fit specifically into the API. They're used elsewhere in the services and in the database layer, right? It's a way to pull those out. These are defined, the .d kind of globally as a declared namespace. And that's kind of what that structure means over there. All right, so we got through types, we got through the API. The next thing that we're going to go to, again, as we saw from our user API, is we have the user service, right, or the services. All right, so we go into the services directory. You can see that we have a service factory. So this uses the factory design pattern that exports a service factory as a singleton, in this case for the factory. And the way that this is set up is we have our service key. So when I need to use it, it's user service. If we look at this guy, you can see he was using a v2, which isn't actually right. So he would be user service. We would import this guy, and boom, now our get is actually working. It's registered to the user service in this case. Here's our user service class, right? So that's what the service factory is. The create is called from our API, not from our API, but from our app on here. So let's see, we have our service factory create, right? So that's where everything gets initialized when the app starts up, and we kind of march down through there. It initializes our factory, which starts all of the services and registers all of those. You can see that we do have dependency injection as well for sending through that database connection. So just something to keep in mind. If user service needs additional tables, you will want to put those in here for that dependency injection. We'll look at that in a moment. Then we have our services. This is a parent base class that has a few methods, or a method in this case, start, which allows a service to instantiate another service. Otherwise, you may get circular dependencies that can happen if a service needs another service that needs that same service, and you kind of get into this endless loop, and things blow up and go bad. Right? Circular dependencies are not good. So that's what the start does. It kind of handles that for us. Now, if we go into the services, you can see that this is subdirectoried, as we have the user directory with the user service, and then AI user service or interface user service. All he is the interface specifically for the user service itself. So if the user service needs specific things, as it interfaces with many different data sources, this is where those interfaces live. If we go into the user service, you can see that it is just user service class, extending that service. This is where the dependency injection comes in to play. If we needed to include another service, we would do it here, where we can ensure that the factory takes care of initializing that service for us so we don't get circular dependency. One thing I do want to emphasize is the heavy TypeScript in here, right? We do define all of the parameter types that come through. We define the responses that are on those methods. It is very, very strongly typed with all of the pieces that we have here in the server. It will save a whole lot of headache, particularly when you get into a very complex multi-tenant system. Knowing exactly what's going on is very, very useful. That is the service layer. Like I said, this is where the business logic takes place. So for validating an email type, if we're going to just pass through data, if we're going to perform whatever logic we want to do on an auth, this is where that happens, right? Is in the service layer. From the service layer, we're going to go into a data layer. In this case, we have dependency injection. So we're injecting in that dependency, that data source that he is going to use. The nice thing about doing this is it allows testing or swapping out any sort of data layer to happen underneath the hood. The service doesn't need to know about it because we're going to tell it what it needs. So in this case, we have the user table. So we would then go into database, tables, user table, right? And here is our beautiful user table. Inside of here, as we'll kind of get into in some of the examples, this is where we will write our SQL and everything in here. This is a connection into our database. So our user table obviously is our user table in the database. Just some things to point out is the MySQL promises. This kind of wraps the MySQL query command with our run query, our query one. The distinction is query one will throw an error if you do not get a single row back, and it expects only a single row. So if you get more than one row, it's going to throw an error. If you get less than one row, it will throw an error. Run query is the exact same thing as query. It just wraps query and wraps it in a promise so you can use the lovely async await on a database query. Connection, you shouldn't have to mess with too many of these. but it is nice to know. So connection is where we handle all of our requests and everything to the database. That's where these connections actually, as you can see, we have MySQL here. This is where the actual connection and creation of that pool or that database connection live. We have the database. So this is our representation of what the database is. So if you add a new table, it will be added to database. You would add the table type, and then bind into the constructor, whatever that happens to be, and initialize that data source here. Again, passing in that connection that we made previously, and then referencing the table. So anytime you need to add a new database table, you add the table as we did previously. You have to add it in the database as well. We could have this so it just reads in, but we don't currently. That may be subject to change by the time you watch this video, but that is how it is here. The database is set up as a singleton. Again, that singleton design pattern. So we don't have a whole lot of connections hanging out there, not terminated. And again, can get into some problems. So super simple, super straightforward. We create our singleton from our app, and then we request that singleton and pass it down through. We have our database utils. This manages getting a few niceties about the database. He gets the column types and kind of all of that stuff. You're more than welcome to go through and look through these if you'd like to. And then table. Table is a base class that all of the other tables inherit from. Table is beautiful and lovely, and it gives you a whole lot for free. So if you want to determine whether you have a clustered database, it will do that. If you want to get the columns off of your table for whatever reason, it will do that. And these are all inherited, so our user table has all of these. If I wanted to overwrite them, I could, assuming they are protected. But they are accessible. They're there. Our create, right? All of the tables that we have will have a basic create function. If you want to change the response, you can change the get by ID, overwrite that method, and voila, it'll still do the create. It will just call the user's version of get by ID or whatever table you're working with. And it has several of these guys. Again, they're all generics, so you can tell it what type it is going in and what type is coming out. Now, one thing that is important to know is you can lie to TypeScript in this case. With query, it doesn't actually know the type that's coming out. It can know what's going in, as that is a parameter, and then relative to the rest of your app. But the type that's coming out, you have to do your due diligence and make sure that you have the right interface associated and set up there, because it comes out as a string, and we parse that string in our connection here. So as it comes out of the database, we parse that and do a lot of nice stuff, convert types and all of that stuff. So it is a well-conformed TypeScript system, without having to take all of the raw strings and then parse the string. And anyway, on every single request, we do it in one place, hand it back, it takes care of it for you. But with that being said, you can lie on the types. So it's very important to ensure that your response types are accurate to what your query is actually doing. Anyway, so just some due diligence there. All right, that's really it for the table. I know we talked about middleware before. We have our validation, API validation. This is where the validators actually live. So this will determine that your username is a string, your password is a string. If you're going to update something and then you don't pass through more things than this, and TypeScript will catch it. So if I were to say there's a test value and it's a JSON decoder of string, TypeScript says, well, no, it's not, because we're using these types that we have to find, and we're saying that it's an object strict, so it cannot have more than what's in that interface. We have our API validation. So this will just, it's kind of a smart method that will determine which validation file to get and which method inside of that validation file to get. And if it doesn't have it, if it doesn't exist, it's just going to print out a warning for you in your console, as you'll see, telling you that there is no validation on there. So you need to go add validation to your endpoints as you need them. So the base validation class, he just registers the validation for us, And then again, we have the factory pattern with the singleton here for registering all of those validators and making sure that they're registered in the factory. We have a few other things in our middleware. We have the authentication that will determine and get the user token for authorization going forward, or hand it off as a public request, or throw the error. And he kind of checks the headers and does all of that stuff here. And then we have our generalized error handler. So in our API, if you throw, we try to standardize the response as it comes out with an error and a message, as you can see here. So we have the error, the message, and then we can log this out to any of our logging system or whatever we want to do beyond that. All right, and then finally in the server here, in our general server setup at least, we have our utils. So this has our bcrypt for cryptography library. As passwords come through, right? They come through as the client typically is an MD5 hash, and then we run that hash through bcrypt and store that into the database on the user object. We have our config, which reads in from our config JSON. This is an interface to ensure that our config adheres to the to what we expect. Otherwise, he's going to throw an error and our app won't start. We have our errors. So this is what tells us about the different error types that we can have. So here are the response codes, and then these are all of the different error messages that can be relayed. And then we map those to response codes. So, we can have a connection error. And if we look at what connection error is, well, he's actually a network timeout, which is 599, so on and so forth. That's kind of how that works. If you have a forbidden, he'll map to the forbidden request or status code. Generalized error handler, super nice. We have our logger, which is a standardized logging, and he can also send logs out to Datadog or whichever log monitoring system we want, in this case, Datadog. And then we have utils. Utils are awesome. It is the same utility library that we use on the front end and the back end. And it's just a whole bunch of very, very useful utilities for all sorts of things broken out into our different classes for whatever it is you're trying to do. We do need to backport a few of these back into the framework, but as the framework may be moving, anyway, just a few things there. But all of the utils that we have, again, overloaded. And then we do have our base utils that come with everything that have been backported. And that's where those are. And anyway, so that's really it from a high level. I know there's a whole lot here, a whole lot of pieces and, things to look at and explore. This is, again, very boilerplate overview of the structure of our backend code. We'll get into the details of each one of these and setting up some custom routes for the challenge as we go forward. So anyway, thanks.